Question number 12 is very similar to the perimeter area questions that we've done a lot in the last week. What it says is a rectangular plot of land is fenced in using two kinds of fencing. So we have a rectangular plot where we're going to call the heavy duty fencing Y and the light duty fencing X. So that means the fence is going to look like 2X plus 2Y is my perimeter. Now, what we don't know is what that cost looks like, but that's how much fence we're going to produce. The cost, if one is 3 and one is $4 a foot, the cost is going to be 6 for the X if that's the cheaper one, and 4 for the Y, so that makes that 8Y. And we know collectively that's going to cost $8,000. And what we want to do is we want to optimize the greatest plot of area. So we want to optimize the area. So we have our perimeter leading to the cost of the fence. And now we want to optimize our area. So we want to maximize XY. This is pretty similar to the ones we've already done, except you had to multiply it by 3 and 4 because of the costs. So rearranging this equation, the easier one is probably to solve it for Y. Y is going to equal 8,000 minus 6x divided by 8, or Y more simply is 1,000 minus 3/4 of x. If that's the case, then xy can be x times 1,000 minus 3/4 of x, or 1,000x minus 3/4 of x squared. And that can be my function. So my derivative is going to look like 1,000 minus 3/2 of x. So the next thing I need are my critical values, which is when that equals 0. So my critical values are when 1,000 equals 3/2 of x. Bringing that over, x equals 2,000 over 3, or 666.6 repeating feet. Now, the other thing we might need is y. To get y, we plug back into our original. So y is equal to 1,000 times, nope, not times, minus 3/4 of 2,000 over 3. Well, the 3's cancel. 2,000 over 4 is 500. So this is just 1,000 minus 500. So y is equal to 500. So now we just need to do two things: justify our answer and make sure we've answered the question. So it wants the dimensions. So my dimensions are simply 2,000 over 3 feet by 500 feet. And to justify, we're going to take the second derivative. My second derivative is just -3/2, which is always less than 0, which is concave down, meaning we have found a maximum, which is what we wanted. So the answer to my question is